Mathestic. Welcome back to Teacher Sol's classroom. I'm your Mathestic Maestra, Teacher Sol. Our lesson for today is evaluation of functions. The learning objective at the end of video, you should be able to substitute values in a function and evaluate a function. What do you see now on your screen? Correct, it is a machine. Functions is like a machine. You put some object into its input panel. If the input object fits into the panel, then the function machine will process that object and turn it into some other object, which comes out its output should. In this illustration, the input is the sphere. The output is illustrated by the polyhedron coming out of the chute. Hence, this function transforms each sphere into a polyhedron. A function rule describes how to convert an input value x into an output value y for a given function. A function f takes an input x and returns an output f of x. How do you read and write function? You can write it using a function notation, and you can read it like this: f of x is equal to the given. Another writing that is, we can also use g of x, h of x, and other letters. Let us consider this example. F of x is equal to 2x plus 1. You read as, again, f of x is equal to 2x plus 1. Now, you can rewrite it as y is equal to 2x plus 1. Notice that f of x and y, when it comes to function notation, they are the same. We call this as equivalent function. How to evaluate function? Evaluating a function means replacing the variables in the function, in this case x, with a value from the function's domain and computing for the result. Let us try this example. F of x is equal to 2x plus 1. You can rewrite this to y is equal to 2x plus 1. F of x, your x here is considered as input, while 2x plus 1 is the output. Let us evaluate this example. F of x is equal to 3x plus 4 if the x is equal to 2, meaning you have to replace 2 to the variable x. So you need to find f of 2. If f of x is equal to 3x plus 4, first, copy the given value. Let us move on to the next step. Second step, f of 2 is equal to 3 times 2 plus 4. Replace x with 2. Third step, f of 2 is equal to 3 times 2, 6. Then, copy plus 4. You need to simplify this one, so 6 plus 4 is equal to 10. Thus, f of 2 is equal to 10, our final answer. Evaluate the following functions at x is equal to 2.5. First, copy the given. F of x is equal to 2x plus 1. Then, replace x with 2.5. F of 2.5 is equal to 2 multiplied to 2.5 plus 1. Next, you need to simplify. F of 2.5 is equal to 2 times 2.5, that is equal to 5. Then copy plus 1. We have now 5 plus 1. The answer is f of 2.5 is equal to 6, our final answer. Another example, Evaluate the following functions at x is equal to 2. Copy first the given. Q of x is equal to x squared minus 3x plus 2. Q of 2 is equal to 2 squared minus 3 squared plus 2. You need to replace x with 2. Q of 2 is equal to 2 times 2, 4. Negative 3 times 2 is equal to negative 6. Then, copy plus 2. You need to simplify by adding 4 minus 6 plus 2. The answer now, Q of 2 is equal to 0. Evaluate functions at x equals to 3. The given r of x is equal to 2x plus 1 over x minus 1. Let us replace 3 to all variable x. So we have now r of 3 is equal to 2 times 3 plus 1 as the numerator and 3 minus 1 in the denominator. Let's simplify. 2 times 3 is 6 plus 1. Then we have 3 minus 1 is equal to 2. So simplify 6 plus 1, we have now 7 over 2. So 7 over 2, our final answer is 3.5. Our r of x is equal to 3.5. Given this example, evaluate the following functions at x is equal to 3. G of x is equal to the square root of x plus 1. That is the given. You need to replace x with 3. So, we have now g of 3 is equal to the square root of 3 plus 1. Simplify it, we have now 3 plus 1 is equal to the g of 3 square root of 4. Let's answer. Square root of 4 is equal to 2. Thus, g of 3 is equal to 2. Our final answer. How about if the given x that you need to replace is a binomial? Let us consider this example. Evaluate the following function at x is equal to 3x minus 1. Prefix or copy the given first. F of x is equal to 3x plus 1. Then replace or substitute 3x minus 1 to the variable x. Using distributive property, let us distribute 3 to 3x minus 1. 3 times 3x equals to 9x. Then, 3 times negative 1 equals to negative 3. Simplify now, we have f of 3x minus 1 is equal to 9x minus 3 plus 1 from the original given. The answer now is 9x minus 2. Thus, f of 3x minus 1 is equal to 9x minus 2. Evaluate the given function q of x is equal to x squared minus 2x plus 2, where x is equal to 2x plus 1. Replace the x with 2x plus 1, so we have now quantity of 2x plus 1 squared minus 2 times 2x plus 1 plus 2. Using FOIL and distributive property, we can now solve the given function. 2x plus 1 times 2x plus 1. First, 2x times 2x equals to 4x squared. Outer, 2x times 1 equals to 2x. Then inner, 1 times 2x equals to 2x. And last, 1 times 1 equals to 1. For the distributive property, negative 2 times 2x equals to negative 4x. And negative 2 times 1 equals to negative 2. We can now combine like terms, which are 2x plus 2x plus negative 4x. This result is 0. Then for the constant term, 1 minus 2 plus 2, the result is 1. Therefore, q of 2x plus 1 is equal to 4x squared plus 1. If you learned from this video, please don't forget to subscribe and press the notification bell for more updates for the upcoming video lesson. Please do like, comment, and share this video. Thank you for watching. Happy Mathematics learning!